Hello there. Just wanted to. I thought I would quickly give you a. I'm not really sure what I'm going to name this video. It depends how it goes. I was thinking about, the whole thing that started this bit off, the thing about the office and our crash. The system was crashing, and I wanted to get a stack trace from the store systems, and I don't remember exactly what I did in order to make it, bring something back that we could look at. But I do remember one of the things. My boss he was a great guy. And I remember thinking, like, how I had before. It's gone now. It's all put into common. This debug stuff. I had that thing that returns a TS string for the symbol lines and so on. That was all very nice and pretty. But of course, that's using TS string, right? And I had a similar dilemma back then, and I asked Blake, my boss. I said, "So do you think I can rely on using the Z string class?" The string is called Z string, something like that. And he said, I think he said something like, "Well, I don't know. That's your call. This is it's your baby now. You just do what you think is right. He wouldn't give any advice on anything." But I think probably he was, well, for one, I'm sure he was fed up of thinking about it and happy enough that somebody else was, thinking about the problem, and he didn't have to. And seriously, he didn't want to interfere. He was one of those guys that I think if it worked out good, he didn't want to be able to take any of the credit for it, Like, I might say, well, if it hadn't have been for Blake giving me such and so advice, then he wouldn't accept that. He wanted me to just do it on my own, with my own ideas, and so that was that. And so I thought about it, and I thought about using the string class. I had something similar to what I had before, using the symbols DLL and so on, and using our string class just for ease in development. And then, I thought to myself, well, maybe I can't use a string class, but what if malloc is not working, And I mentioned that to a few people, and they just sort of laughed. And I didn't think it was funny. It's possible that this system's in an unstable state. Maybe malloc's not working, Maybe I shouldn't trust that I can make a string or do a malloc, something like that, right? So I know I did something similar to what I've got here. First off, I was reading through that paper, and I don't even have a local copy of it. And I know I didn't get to the end of it. It started getting a little bit strange. It was down here. Here. See, at some point, after the exception filter gets called, The system does a second walk through if there's a chain of exception handlers, and it tries to roll the stack back to the point where you can enter, like if I want to jump into my exception handler, there's an unwind that goes on afterwards. And of course, that was the last thing I wanted, was anything to unwind. I want to take a snapshot of the way things are now, right? Yeah, so somehow, I forget how it happens. But somewhere in here it describes this. Oh, here we go. First time through, and two, the second time, the subject of unwinding. When an exception declines, well, I wasn't declining. It's called second time. But it's okay. So anything down the road that might have declined, any exception handlers that might have been placed down the line, that would have been for some other kinds of exceptions, I guess. If they had declined, they would get called again to do cleanup steps. See? Cleanup. Perfect example is a destructor. Well, the last thing you want, right, is I want to see the way things are exactly at the point of the crash, and I don't want any destructors or anything being called because I want to get a picture of the way things were at the time, exactly when the crash occurred. So I must have had something similar to what I've done here in this thread except filter. So this is the thing that's being called. When a crash occurs, it's on the same file. When a crash occurs, that leaves you on this line, right? With no unwinding, first time through, and so first thing is no mallocs. Okay, so step one in how to become a programming legend. Step one: make sure there are no mallocs. Now this is something that I've just added. This sets up locks a critical section, so only one thread has any access to the symbols thing. That being me, and I have no intention of unlocking it. Now these are just regular old pointer assignments. That's safe to do. No malloc. Now there's this fprintf. Okay, now what I'm trying to do is print out the report, and then I want to go through the stack walk, which is here. This is the stack walk as before, and then execute handler when I've done that. Now, so first things first, remember that you only get your one chance, right? And my one and only task is to get that report into that file and get the hell out as fast as possible, right? So that means set up as much as you can before the exception occurs. So this is where the sim initialize call is done here. Now it's okay. I'm using TS strings and stuff here because the system's in a stable state and I can do that sort of thing, right? This is at program start. I don't need this anymore. Previously I was doing the lock here, but I decided best thing is to have this called early on in the program to make sure everything's set up. What you want really is your system. Think of it like a cocked gun or something. like poised to go and fire for the first and last time, right? In accomplishing its single task to get that data into that file and then just die, like reboot the machine. And that's what I wanted to accomplish. And so I would have done something like this, set all this up first while the system is in stable state. Now what I've done here is I've gone back to, programming 101, and there are all of these buffers are on the static heap, okay? These format strings, and this is where the symbol names are going to come back in a single static buffer. Just like you're programming like a baby, getting a symbol string. Now this should already be locked because I'm going to call this acquire, which locks that critical section. That critical section is a global, so it's initialized before the program main or anything gets called. And I'm going to lock that if there's a crash, if my thread accept filter gets in. Now I have all these static buffers. So I've got to do everything the old-fashioned way. I've got to use split path to extract the module file name from a string that's obtained. I still have to go over how this works, but showing you, assuming that this is possible, given an address to retrieve an H instance, you can get the module file name, which goes into a path, which is just a static global variable called stc path. Well, it's here. It's local to this scope, it turns out, but it's not changing from one invocation of this function to another. No, I'm not using any stack here for anything. Very little bit anyway for some function calls, because you don't know how stable your stack is either, how much there's left. Now here's my this is the Unicode version. I added Unicode support, so here's conversion from Unicode to multi-byte, right? Just a cast, straight up cast, which is good enough for our system. Everything here is designed given exactly what I know about the situation. I'm making the assumptions. Normally, you shouldn't make assumptions, but you're in a situation where you know what this system is. This code is not portable. Okay, yeah. Think for a second and ask yourself, how much do you think the bosses cared about portability at this point, right? They're losing the system, one sale is close to $500,000, and they're losing sales. So quite a lot of money at stake. But see, so therefore they don't care, or they couldn't give a damn about if it's portable or not. They just want the bug to be fixed and to get little people off their backs and get back to their normal state. The program had never crashed before any of this. So this here is a static global. Here I've worked out the maximum possible length it can be, allocated at program startup, along with these others. No TS strings, so I'm not relying on mount. Now, all these functions do are move data from one place to another. They don't use mount, right? So nothing in here uses any allocation, and there's a very small amount of stack usage con some functions. This one, and of course these ones to get the symbols out. that much I couldn't avoid. If I can just get out of here. It's horrible to look at. God, get out! I think we're back to where we're supposed to be. So here's now what I want to do is I want to do the thread dump during the filter. So I get the reason for the crash. Again, this is just a static global. Now, these are fprintfs. So again, going back to the cocked rifle or whatever, ready and poised to go. That file is opened at as soon as the program starts up. This is called, and that's when I open that file. And this is a critical step. I'll show you why in debug mode. And I realized this, thankfully, before we ever sent anything, that if you want to open a file so that you don't have to invoke the fopen and all the streaming functionality, just right in the middle of your exception filter, which you don't. You want it open and ready to be dumped. There's one thing you have to do first. And that's this. Okay, now here I'm just fopen. Now I'm allowed to use, these are TS string things. I'm allowed to use those here, but I'm not allowed to use those in this, anything like that in this function where there's a try except. So I had to move those out here. And you get a warning, an error in fact, if you try to. Okay, so the file's open. Next, of critical importance is to write at least one byte to the file. And the reason is going to come up. Now, this here, that's stir. The thing you want to keep your eye on is stream. Okay? Yeah, stream. Okay? Now currently, stream, that's the output stream. And the way that the outputting function works is it caches 4 kilobytes of data before it writes anything. Okay? One page. That's the minimum amount you can write to disk anyway, right? So you can only write pages, even if it's not all used. Okay, now this just does a log. We'll get in here. Now there's this buffer. See, it doesn't write anything to the disk until it's ready. Until you say, please write. Okay, now I don't know, this is it a TT1? Do nothing if not a teletype device. Okay, it's not a teletype, I guess. So that doesn't do anything. Now there's this output, stream, format, blah, blah, blah. You can just step over it. There, see? Now, writing that single byte has completed the allocation. It should be 4 kilobytes allocated. It won't need to be allocated at the time of the crash. That doesn't say here. Buff size is 1000 hex, which in decimal is 4K, 1 page. So that has to be ready and allocated so that no mallocs are going to be used when we start to try and write out to the file. Critically important. You might think, well, whatever, sure malloc's going to work. Well, okay, now I'm going to run this program, and well, it's going to crash. I'm going to just stop here and run it outside of the debugger. Let me show you the message box show up. I put a crash somewhere in the program. So this would have been the type of thing that would come up, a message box, and when you pressed OK, it just reboot the machine. By this point, okay, the file's been closed, and this is up here, which is good, which allows for a little bit of time to make sure that this flush happens cleanly, and then we're done. Now, in here's the dump file. The critical thing that has to get back to the office so that I can look at it and try to make sense of what's going on. I happened to put the bug in the Rex class and have this printout. Now there was no malloking or anything that went on through this entire process. And that would have been a good thing in our case, because the first line here was this. That was where the crash was. It was within malloc. Okay, so in fact, if a malloc was required, it would never have. This wouldn't have succeeded because malloc would have called a lock function, which it does, and any further attempts to malloc would have just resulted in failure. But all of this was set up, everything was pre-allocated, ready to go, to shoot, fire off as soon as the crash occurred, which occurred in malloc. I suppose it was a debug malloc. And of course that made very little sense. And it took us quite a while to figure out, it took me quite a while to make the mental leap that was required in order to see how this, because this, after the next week or so, and the next report came along, it was the same spot. And down below here, it was always like a RTTI something in their mangled naming convention, right? Something always RTTI, malloc crash. Okay, of course it only happened once in a while, but once in a while is enough. And eventually I dropped the assumption that malloc was thread safe and just supposed it wasn't. And then I came up with a scenario which was obviously the reason what caused the crash. I remember explaining to my boss that I've solved the bug, I fixed it, or whatever, I know what it is. And he's like, yeah, whatever. I'm trying desperately to keep it in my head so I don't forget. And then after I explained it to him, he immediately said, well, obviously that's it, right? It's clear, but it's this multi-threading stuff. You can't until you've hit the answer. It's a complete mystery because it's a very convoluted world. There probably still are bugs in malloc. When I looked at the code just now, I was looking at it, and I could think of thousands of scenarios that it looks like it could go wrong with, but I don't know. It's hard to tell. But see, so the combination of making sure to write out that one character to make sure that this thing's ready to do its job, and making sure to not rely on any mallocing anywhere within the stack walking, and then to do the stack walking from where you're not supposed to really do anything, right? In this filter, because it's safe. It's safe if I'm just writing to static buffers, right? I'm not allocating any memory, not using malloc at all. And the debug help lib has its own private allocator. Another solution would be to make your own allocating library and use that, right? But I just took the quickest hack to try and get to the answer as quick as possible. It took a while, it took several weeks before, maybe 2 or 3 weeks before the answer came. Yeah, so I put the crash, better fix it. So I put it in the poor old TS Rect always gets to be the one that crashes. So expand, was it? Same place I put the last crash. Or something. Some other kind of bad thinking here. So anyway, I just thought I'd mention that even with the little bit that we already know, there's enough to do that sort of thing, right? There's a lot more that I haven't explained, about those modules and getting that information. Anyway, I just thought I'd show you that you even with this, that's enough to do a crash report. That's a crash report. But normally, what we would do is you just have a number and increment the number each time so you don't lose anything. Really, this was of completely very little use. Because the crash was happening inside of the runtime library, and we could look at we had the source code, but we don't have all the header files and everything that correspond to all the various tables and whatnot to look at. So. But anyway, it works. You see, in this case, all I'm doing, instead of what I was doing before, is using the context, using that P context, right? Current address, I use P context. And then again, verifying the caller is a matter of taking this displacement from the current address to the closest symbol. That there gets me this symbol, the first one, contains an offset, right? So we would find out exactly where in malloc. Of very little use. I think I might have gone one further step, but managed to get the code line number. We can do that with this thing, and I'm actually set up to do it. In the initial ones, it's set up for line numbers. Oh yeah, I guess. Oh no, that doesn't get called. See, not done in yet. And you don't want to. In fact, you would never call this. What you want here is a port. But if I call a port, then it gives an ugly message. I don't want to do that. We had a function something like this. It just silently reboot. Now where's that sim initialize up here? See, oh well. If I uncomment this, that means it can give you the line number, the C++ line number, rather than just the byte offset, which would have been maybe of some use because we have the source code for malloc. We could have looked at But it wouldn't have made much sense. It was too hard to figure out. Now, now the funny punchline to all this, okay, which goes way back to a video a long time ago. I said there was a funny story I had to tell about multi-threading, and this was that story. See, because the reason that was saying malloc, and the thing calling it was RTTI something, had to do with those runtime type info names. You know that type ID of some type dot name. The famous memory leak. This thing is always a memory leak. Well, that's the one it was crashing on. And so that was and this thing leaves a memory leak. Okay, now the fact that this thing leaves a memory leak was a clue as to what was going on. And that is that these things, okay, when you call this thing, it does a malloc for the name, so that the next time through, if it sees there's already a pointer, it doesn't have to do it again. Okay? And it never frees them. It tells you never to free them. Now that's already a multi-threading bug, right? But it's not a serious one. Like you have something like if p name. If we don't have a name, p name now some size, right? And then you stir copy p name, etc., right? And the next time through, you don't have to allocate this thing and copy the name. But if there are two threads that hit this line at the same time, right, they can both see null, as long as the one thread doesn't complete this line before the next thread gets in here. Now that is a bug, okay, but it's not a serious bug, because what's going to happen is one or the other of them is going to assign something here, and what's remaining is another memory leak. But it's already full of memory leaks. Who cares if there's one more little memory leak, right? So that means the bug, although this is a bug, and they're probably aware of it, the real bug has to be inside here, right? Inside malloc. And so malloc had to have been not said thread safe, and in fact it wasn't. And so the first thing we did, since we had a hook on malloc, was to just surround the whole thing with a critical section, and that of course stopped all the crashing. And then we went back and tried to see what had changed. And what had changed at the time when the crashing occurred had to do with simply interchanging two lines of the code that caused a race condition to reveal itself. There was a race condition, meaning that there were this kind of thing with two threads taking the type name, okay, of the same object in two different threads at the same time could occur, right? But prior to that, it wouldn't have ever occurred because of the way it was set up. In the one of the threads, that line was a little bit later than it had become, and so the two weren't nearly simultaneous, and everything was fine. Because once this is through, it's good. It goes forever, right? But if the timing is just right, and the timing changed from the interchanging of those two lines, then you get the race condition and the crash. Very unreproducible, ununderstandable, and seemingly nothing had changed in the code. In fact, we looked at that code. I looked at it. We both looked at it. Me and my boss. Excuse me. And we both concluded that nothing had changed, right? Couldn't see any difference. Even the file difference thing it wasn't obvious that two lines had been flipped. It doesn't show up like in red or anything. Okay, anyway, I just thought I'd let you know about that little story. I'm not sure. I'd like to go on and do a little bit more, looking at this, the way this goes. And a couple other things I'm thinking about. There are a bunch of things that I've been doing that I didn't say anything about. To do with this editor, for instance. I added a bunch of features that are quite nice. Oh well, anyway. Till next time.